Hello students, new chapter metallurgy. In metallurgy, first one minerals. This minerals, it is a naturally occurring compound of metal. It is a naturally occurring compound of metal. Metal like gold, silver, lithium, zinc. This metal generally mixed with the other matter like soil, sand, limestone, rocks. This is known as a minerals. Then it is known as a minerals. Metals mixed with the sand, soil, limestone, rocks. Then it is known as a minerals. Now ore. Those minerals from which the metals are extracted. Those minerals which are metals are extracted commercially at a comparatively low cost with minimum efforts are called ores. Now, some metals present in ore like bauxite containing aluminium, lead containing galena PbS, Fe containing hematite, iron pyrites, mercury containing cinnabar, calcium containing marble, calcium sulphate, gypsum, magnesium containing carnelites, dolomites, zinc containing zinc blende, ZNS, calamine. This is the main ores which containing metals present. Important ore of aluminium. This important ore of aluminium, first one is bauxite and its formula Al2O3 dot 2H2O. Al2O3 dot 2H2O. It is a formula of bauxite. Aluminum oxide dihydrate. Aluminum trioxide dihydrate. Bauxite formula. It is the first important ore of aluminum. Second one is cryolite. And its formula Na3AlF6. Na3AlF6. Sodium aluminum fluoride. This is a name. This is a ore of aluminum. Its name cryolite. Second or cryolite. Third one corundum. It is a anhydrous aluminum oxide and its formula Al2O3. This is the importance ore of aluminum. First one is bauxite. Its formula Al2 dot 2H2O. Second one is cryolite Na3AlF6. Third one corundum anhydrous aluminum oxide. Its formula Al2O3. Aluminium is it is a most abundant metal in earth crust. Aluminium is reactive metal. It do not occur in a free state, free in nature. This aluminium extracted from main ore of bauxite, main ore of bauxite, Al2O3 dot 2H2 dihydrate. In bauxite containing 60% Al2O3, 60% Al2O3 and rest it containing sand, ferric oxide, titanium oxide. Aluminium, symbol of aluminium is Al, its atomic number 13, its electronic configuration 2, 8, 3. So, its valency plus 3 and its atomic mass number is 27. Its color, it is a silvery white metal. It is a silvery white metal. This bauxite, conversion of bauxite into alumina by Breyer process. This is a concentrated of ore, that is conversion of bauxite into alumina. This is a Breyer process. On this process we obtain aluminium, pure aluminium. Aluminium from Breyer process. Bauxite is grinded finally and heated too. It is for remove volatile impurities. It is used for heated finally powder for remove volatile impurities. Then it is heated with caustic soda. Caustic soda means NaOH. Under the pressure, concentrated caustic soda solution about 2 to 8 hours at 140 to 150 degrees Celsius. Bauxite first heated to lose volatile or remove volatile oxide or volatile impurities. Then it is heated with concentrated sodium hydroxide means caustic soda about 2 to 8 hours at 140 to 150 degrees Celsius. We get sodium aluminate Al2O3 dot 2H2O. It is bauxite. It heated with sodium hydroxide NaOH at temperature about 150 degrees Celsius. We get NaAlO2, sodium aluminate, and 3 times water. In this, we are NaOH used as a 2 times, then we get the product 2 times NaAlO2, sodium aluminate. In this, bauxite dissolve in sodium hydroxide to give sodium aluminate. In this, some part are left. This is a red mud color. This is a insoluble This insoluble, it consists of ferric oxide, sand, etc. This removed by the filtration method. Now we get the sodium aluminate, which are dilute, means addition of water, and cool at 50 degrees Celsius. Means addition of water means hydrolysis takes place. In hydrolysis takes place means addition of water, sodium aluminate convert to aluminum hydroxide. It gives aluminum hydroxide, NaAlO2 plus 2 times water. NaAlO2 plus 2 times water, we get AlOH thrice, aluminum hydroxide, and byproduct NaOH. Byproduct NaOH. It is precipitate of aluminum hydroxide. This precipitate filter, wash, dry and heated about 1000 degrees Celsius, we get alumina. We get alumina. Aluminum is Al2O3. Now this precipitate of aluminum hydroxide heated about 1000 degrees Celsius, we get Al2O3 and water as a byproduct 3 times. This aluminum oxide is great affinity towards the oxygen, so it is a very stable compound, so it cannot be reduced by the some reducing agent like carbon monoxide. Al2O3 alumina cannot reduce by carbon or carbon monoxide or hydrogen. These are suitable reducing agent because aluminum with oxygen, aluminum oxide which containing affinity of oxygen is great affinity, so it is a more stable or very stable compound. Now first alumina means bauxite Al2O3 dot 2H2O react with sodium hydroxide, concentrated caustic soda, we get sodium aluminate. Sodium aluminate as a 2 times and 3 times water. This sodium aluminate again hydrolysis, we get AlOH thrice, aluminum hydroxide, and byproduct NaOH. This aluminum hydroxide heated about 1000 degrees Celsius, we get Al2O3 alumina, and this alumina we are using suitable electrolytic reduction method for preparation of pure aluminium. Next, electrolytic reduction of fused alumina by Hall-Héroult process. This diagram for extraction of aluminium. In this electrolytic cell, this is the rectangular iron tank. This is a rectangular iron tank with sloping bottom. The sloping bottom of the tank facilitates the removal of molten aluminium. This is because removal of molten aluminium. So it is its bottom as a sloping manner, and the tank is lined with the gas carbon. This tank is lined by the carbon. This carbon as a cathode. This carbon as a cathode. Now in this electrolyte there are mixture of, we are using mixture of pure and molten alumina as a 20%. We are using alumina as a 20%, Al2O3, and also addition of cryolite Na3Alf6, sodium aluminum fluoride as a 60%, and also addition of fluorspar, about fluorspar means calcium fluoride, about 20%, 20% alumina, 60% cryolite, and 20% calcium fluoride, fluorspar. This is a mixture. In powdered chalk is sprinkled over the surface of the electrolyte, and there are temperature about 950 degrees Celsius. The molten electrolyte kept as a 950 degrees Celsius, and also we provide voltage about 5 to 6 volt. We are using low voltage because it avoid decomposition of molten cryolite. We are using low voltage because it avoid to decomposition of molten cryolite. Now look this diagram containing carbon lining cathode and carbon graphite anode. Anode is positive charge and cathode is negative charge. Now reaction: cryolite, fluorspar and alumina. It form electrolyte. Electrolyte means it form ions. Cryolite form 3 times Na plus ion, 6 times F minus ion and Al plus 3. Fluorspar form calcium plus 2 ion and 2 F minus ion, and alumina it form Al plus 3 ion and 3 times O minus 2 oxygen. This positive ion form in the solution Na plus, Ca plus 2 and Al plus 3, while negative ion F minus, O minus 2. In this cation aluminum Al plus 3, it is lower in electrochemical series, so it discharges on cathode or at cathode. Cation move to cathode and anion move to anode. In this O minus 2, oxygen at the anode, Al plus 3 at cathode, O minus 2 oxygen at anode. At cathode reduction takes place, so aluminum Al plus 3 which containing gain of electron, it gives aluminum, and anode loss of electron, O minus 2 ion convert to O2 ion. cathode containing reduction and anode containing oxidation, means loss of electron. When the supply of alumina decrease, the voltage suddenly jump 40 to 60 volt. If bulb is attached to the apparatus, it will glow brightly. At low voltage, it is a less brightly, but when decrease alumina, the voltage increase about 40 to 60, then light bulb glow brightly. Then we add fresh alumina. We obtain 99.8% pure aluminium. Now further purification can be done by the electrolysis. This is the electrolytic reduction of fused alumina. In this way, we use mixture of cryolite, fluorspar and alumina. In this, cathode means positive charge, cathode negative charge, discharge aluminium, anode is positive charge, discharge oxygen, cathode having reduction reaction and anode having oxidation reaction.